Okay. So Huygen's principle says that if you take a stone and drop it in a stagnant water, it creates ripples. We have seen that. Those ripples, we named them as what? Wave fronts. Alright? So Huygen's principle says that you take up any point on a wave front. Say this is a source and it is creating wave fronts. Okay? You take up any point on the wave front that act as a new source of waves. That act as a new source of wave. So it creates smaller waves like this. Obviously, I'm trying to explain that. क्या हो रहा है? Huygen's principle बोल रहे हैं कि when you see a wave front, you see actually the resultant of all small wavelengths. Like if you take up this wave front, any point on this wave front, it creates small wave fronts which are called wavelengths. Okay. Again, you take another point, it will create small wave fronts, which is all its wavelengths. And the next wave front, big wave front, which you can see, is the resultant of all these small wave fronts. You don't see these small wave fronts in actual life, but this final wave front which comes up, it is because of the small wave fronts, and you take tangents to these small wave fronts that creates the next bigger wave front. ठीक है? अब ये कैसे समझ में आएगा? ये इन जनरल समझने में थोड़ा सा दिक्कत होगा, लेकिन I don't know if you have ever observed during the rain or say in swimming pools or some water containers somewhere. So say if you have a pool which is separated by a wall, and there is a small passage somewhere in the middle, so that the water can flow from one pool to the other. Now, if you drop a stone out here, you'll see the ripples will be produced, and obviously they can go for reflection after collision with the walls of the container. They will reflect, and they will overlap and distort the whole thing. But before that overlapping is taking place, the wave front which gets stuck out here, it disturbs the water over this narrow region. And when you see the wave front coming out from the narrow region, the wavefront shape does no longer remain like this. Instead, it appears to be starting from here as new. Okay. Why does this thing happen? It happens because all the wavefronts couldn't pass out to the next part. Only the disturbance which was taking place at this region created or acted as a new source of wave, and that created the ripples afterwards. Okay. So Huygen's principle just says that any point on the wavefront can act as a new source of waves, creating smaller wavefronts. These smaller wavefronts are called wavelets. Okay? And when you draw the tangents to these smaller wavefronts, like if I take many wavefronts like this, over here, many wavefronts like this, then that tangent you draw to these small wavefronts, if you join up all these tangents, that actually creates the next bigger wavefront. Alright? Now you might have a question, sir, if this is acting as a new source of wave, why isn't it producing the wavefront in the backward direction? Right? A disturbance can also produce waves in the backward direction. Now what happens when we make mathematical calculations, we find that these backwards waves, they overlap on one another, and the resultant created in the backward direction becomes zero. The resultant backward movement of the waves becomes zero. So only the forward direction have a final resultant which gives the wave propagation in the outward direction, not the inward direction. Inward direction में नहीं होता है. देखो actually में क्या होता है, यहाँ से जो waves अंदर जाएगा, ये वाला एक wave से अंदर गया, लेकिन इसके पास ही और एक source है, because all the points are acting as a new source of light. new source of wave, and that wave is actually directed towards the original wave, मतलब first वाला wave. तो ऐसे जितना भी तो points लोगे, you'll see that in any internal points, at any internal points, these waves will overlap on one another and they will cancel each other out. The resultant will be zero. That's why no net inward propagation takes place, only outward propagation takes place. Okay, so on that, let's write this down. Huygen's principle. Because every point on a primary wavefront means this bigger wavefront, okay? The one which you can see, those are the primary wavefronts, okay? Every point on a primary wavefront acts as a source of secondary wavelengths. Acts as a source of secondary wavelengths. Secondary wavelengths. The secondary wavelength full stop. The secondary wavelength sends, so what is wavelet? Wavelet is the smaller wavefronts. मतलब waver बात sends out disturbances in all directions. The secondary wavelet sends out disturbances in all directions, just as the primary source of light. Just as the primary source of light. Because we are doing light waves. मैंने वाटर का एग्जांपल क्यों लिया? ताकि तुम लोगों को समझ में आए कि होता क्या है इन एवरीडे लाइफ. But it is actually will be dealing with light waves. ठीक है? क्योंकि तुम लोगों को चीज जो दिखता नहीं है ना, वो समझने में हम लोगों को प्रॉब्लम होता है. So इसीलिए I wanted to make you visualize, but we'll be dealing with light waves. Wave optics deals with light waves and not the mechanical physical waves. Alright? The second part of the Huygen's principle, second part of statement of the Huygen's principle, it says the new position of the secondary wavefronts, the new position of the secondary wavefronts is the envelope formed by tangents drawn to the primary wavefront. Envelope formed by the tangents drawn to the primary wavefront. Tangents drawn to the primary wavefront means well, now see, we can consider the light as waves. चल रहा था